Hey, we've got a little baby one on the healing bench today. This is a Tektronix 212 oscilloscope, handheld, battery powered with mains charging, and it can run off the mains as well. And yeah, this is definitely a baby. Its maximum bandwidth is like 500 kilohertz. And as you turn the volts per division, the horizontal down, you can just see there's a bit of a gap as I turn it. See that gap just there? Once you drop down here, you drop down your bandwidth right down to 100 kilohertz or even lower. It says 2 seconds on some of the lower settings. So yeah, it's a very low spec unit, but it's great for things like, I don't know, working on your car or something in the old days before you had the your digital scopes or your handheld digital scopes. But yeah, it's a cool little unit. It's got all the controls on the side there, 2-channel integrated leads. I think these are, they might have some plugs inside there, you can unplug them if needed, but yeah, they're designed to be integrated. And originally this did come with a case and a strap and even a hood for the screen there, so if you're outdoors, you know, field work, it's meant for field work and field service work and stuff. The hood will then shield the sunlight so you can read the display. So being battery powered, these batteries are NiCads, and they're going to be absolutely shot. So I'm not going to turn it on straight away. We'll open it up and see how bad it is, because I'm sure they're leaking and there's going to be that white fuzz everywhere and hopefully not too much damage to be repaired. So to undo the case, to remove the case, we have to unwrap the leads, and that will give us access to a couple screws just down in there. You might just be able to see them at the ends of my fingers. Then there's this screw here, and these ones, these are some strange looking contraption, but we remove those 5 and then we can undo the case. So let's have a look here, see if we can unplug. Oh yep, they just kind of unplug. Got some little old school sort of almost looking like SMBs, but not quite. The power cable is integrated. Would be nice if that was a plug-in lead, so you could unplug it while you're using it on the battery. I'm not sure if there's meant to be a rear panel on here. I don't have that, so I'm not sure what the go is. Maybe that gets rolled up inside there and you put a back cover on. I have to figure that out. Maybe 3D print something in the future. So what do we got? We have got, looks like Torx. No, not Torx. Posi drive, sorry. Okay, not sure what these were. These are meant to be screws apparently, but they're not. They're just like studs. In the instructions it says there's 2 screws through there, so I'm not sure what's going on there. So let's lift the lid off, see what we get. Shielded inside with a aluminium foil. Looks like we've got a circuit board on top. We've got a board here for all our input stuff, all our controls at least. And where are the batteries? I can't see the batteries. I don't know if they're even still in there. Maybe they don't exist in this unit. Maybe they've been taken out. Alright, let's see how to take this out. I think like that. Nope, batteries are gone. Well, that's alright. That means that the batteries can't be leaking everywhere. So the batteries should be here and maybe here. That's alright. Well, it's looking pretty clean otherwise. Electrolytics. Any electrolytics? I don't see a single electrolytic in there. Nice, there's some tantalums. There's a little harlequin looking thing there. The old style before they printed the numbers on. They used to dip them in paint to get the values, kind of like a resistor. There's a kind of a weird code. You got the bands and then you got a dot on the side. So I'll have to look up how to read that. I've got no idea. But yeah, there's a newer style tantalum there. So the batteries are gone. I wonder if they plug in just down in there. You can see there's screw holes, 1, 2, and there's a screw hole just about there and just about there where the batteries are held in. So at least that saved us a problem of leaking batteries, but it means that I don't have the battery holders. I might have to design something up for that. No electrolytics means we don't have to worry about any old capacitors to be replaced. I'm going to take this board out very carefully. This seems to be the drive for the oscilloscope screen. Let's pull that screen out. Look at that. Beautiful. Ceramic. It's a ceramic one. Part number 154-0699-00. Nice. Tektronix. October 30th week 1974. Is that 30th week? Is it in October? I've got no idea, but it says OCT October 3074, so it's at least October 1974. Looks like we got some carbon resistors down here. They sometimes drift, so I will test those. I've had those drifting in the past. And the tantalums will sometimes go pop, so we have to be careful about that. It looks like they've used tantalums instead of electrolytics in this unit. So hopefully none of those are short. Alright, I got it all hooked up here. Got it plugged into the function generator, 100 kilohertz, so we can see if we're getting the input side of the things working. And ready to turn it on. So I've got the power switch on the side here. See what happens. Nothing much. Didn't hear any noises. Looks like she's dead, Jim. I wonder if it needs the batteries. Where's the intensity? Turn the intensity up. Nothing. Looks like we're going to have some fun. So it turns out that I had to read the schematics a little bit closer, and there's a jumper here in the battery pack, in this side battery pack. You can see I've got this alligator clip here. That's jumping pins 1 and 3 on pin 7 here, which one the battery pack connects to. The other one connects to plug 17, and that is just got the jumper on the board, like there's a trace on the board for that. So yeah, I'll put the alligator clip there and it's all come up and I'm getting the correct output voltages, so that's good. Also, I found that once that came up, the voltage across the batteries, the 2 battery packs, is just over 13 volts, so that's about right for NiCads. So that's not a problem there either. So it's looking good now. So it does turn on, but we're not getting quite the right sort of output so on the screen. So I'll turn it on and I'll turn the lights off and I'll show you what I mean. So you can see there, I'm feeding in a square wave and we're not getting much going on. Looks like we've got no horizontal movement. It's just blipping away on the vertical. So if I turn up the intensity, it also does something a bit weird. It goes away, bring it back, comes back, and then as I turn it up, you can see it does something a bit weird there. So yeah, something's still not quite right. So I've got the correct voltages. The golden rule has been followed. Thou shalt check voltages. And that's been done. I'll get those out of the way. But we've got to look further into the circuit somewhere up here. It might be something to do with a transistor needs to be reseated, or I'll turn that off as well. There we go. Transistor might need to be reseated, or chip or something. I don't know. It could be a bad something or other somewhere. So we'll have to look deeper for that. So what I'm going to do is I'll go and get some batteries from Akihabara, but in the meantime, while I'm testing, I'll just put a little jumper. I'll get a 3-pin Molex kind of connector, or like a DuPont connector or something like you use on your breadboard or whatever, but with female ends, and I'll just jumper that there so it's a bit nicer than this chunky alligator clip. And we'll start looking further into the circuit. So I've been down to Akihabara and got me some battery packs. These are 1x5 AA. One roll of 5 batteries in series, 2000 milliamp hour 6 volt nickel metal hydride. So I've decided to upgrade to a nickel metal hydride from the nickel cadmiums because these are double the capacity. The nickel cadmiums from memory are about 1000 milliamp hour or maybe 1200. These are 2000, so I'm going to get a lot more runtime. Take a bit longer to charge, but we can adjust for that. And yeah, they'll last quite a while compared to the nickel cadmiums. It's not much of a problem with this unit. You've got to be careful if you put nickel metal hydrides in, because if the charge current is higher, like a few hundred milliamps, you can end up burning the batteries out over time if you leave them charging at that current. So that's no worries with the charging. I have got some little plugs to go on the ends of these wires because they came with different plugs which were completely the wrong type. So these are the standard 0.1 inch header female connectors with the little crimps, and they will connect straight on. So also I did put a call out on the groups.io, the Tektronix groups.io group, for some of these caps that I need to put on here to hold the batteries into the circuit boards. And a friendly guy from Sweden, for an exchange of generic currency units, sent me a set of caps. Beautiful. So I'll clean those up with some isopropyl alcohol. They'll clip on, 1 and 2, and then I'll give them a wrap with some capped on tape just to hold it all together, and they will plug in to the holes on the board. So we got 1, 2, 3 and 4, and on the other board as well. On the other side you can see the hole there and there. So these just kind of click in and hold the batteries in place. So it all kind of links together when you put the case back together. I also have the original wiring. You can see here, these are from the old battery packs. I didn't get the battery sent because they were dead anyway. But exactly the same kind of plug. So I'll probably use a new one just because I want to crimp new wires on. And this actually has a little fuse, a 3 amp fuse in line. So I'll get some new fuses for my battery packs. I'm going to make an order for some parts anyway, because I was also, by another member, sent an upgrade, like a bulletin for an upgrade to this unit. When you replace the batteries at that time, the original batteries weren't available anymore, so they had just a different part number for some newer batteries when you bought them from Tektronix. But it had a bulletin that came out that replaced this bridge rectifier with a little circuit board. And that circuit board had a bridge rectifier on it as well, but also like a SCR and some other bits and pieces. So I think it was either a crowbar or a over voltage clamp. I can't remember exactly, but it was like just a bit of protection there, which you put in place of this bridge rectifier. So it would also still do the full bridge rectification, but also a bit of protection as well. So I thought, hey, I'll design that up in my PCB software and get some of those made, and upgrade my unit to the latest and greatest. So I guess I'll get these battery packs ready, and we can plug them in and see if this thing works, because sometimes the circuits do require the batteries. I don't know if this one's so critical, but it's not going to hurt to put them in. And I have found with a few other bits of equipment, like my Fluke 731 DC voltage standard, it does need the batteries plugged in for the voltage regulator circuit to operate correctly, because it uses the batteries to help regulate and smooth out any ripple and whatnot. So I don't know if this is doing anything fancy like that, but we've got the batteries now, so we'll plug it in, get it all complete, and see what else is wrong with this unit. Battery packs are a go. All done. Got the dates put on there so that in the future I know how old they are. And we've got the 2.54mm headers, or socket headers, whatever, on the end, with two little 3 amp fuses in there. They're just like, look like a little resistor. They're like a little 3 amp inline kind of axial fuse on each one, as they added to the later model of these packs. So that's all good to go. They can slot straight in here and here, and then the other board, this board here, will then sit on top and sandwich them in place. So that's all good. Now, as for the other problem we had with the display not showing correctly, I was having a bit of a poke around, just checking, make sure nothing's obviously bad, and I found something. It looks like the Tokyo Godzilla that was working on this last actually damaged one of these gold connectors here. So I'll zoom in and I'll show you. See how far we can get before it loses focus. Okay, we're all the way in. Okay, so I'll grab a pointer of some description. Now you see this one here. It looks like it's a bit bent and there's something missing. There's a little tab inside there, like a little piece missing from inside. So when then the header plugs into here from this direction, that one isn't actually making any contact. Now I've got no idea what sort of plug that is, what brand it is, but I did find the Tektronix part number, and that is the part number, because from a supplier online I got 2 of them. It looks like they're stamped out in one long line, and just cut them down what you need. So I got 2 just in case. I don't want to buy one and then find out that I didn't do it right and I've got to do it a second time, but one for a spare. So I'll just chop it there and chop it there, bend those leads down, stick them through there, remove this one, and that should be good. So hopefully that's what our problem was, and hopefully this thing comes to life. And there is our new one, all installed. Beautiful. Looks exactly the same. That's fantastic. And it does have continuity now. I just tested it with the multimeter. So we're ready to plug this thing together and see what happens when we turn it on. Alright, moment of truth. I've got the thing mostly put back together. I've got the two probe inputs here. One's connected to my function generator with a sine wave. The other one's connected to my other scope, to the calibration output for the square wave. And I've set the settings to what I think is mostly about correct. Also, the plug is not plugged in, so we're going to test that that battery, or the batteries, and let's see what happens. So we'll turn the power on, give it a second, and what we'll get, oh, hang on, I'll just fix the connection there. Yep, that's it. We are working. Fantastic. So is that little connector just about there. Awesome. Winner, winner, chicken dinner. So that is happy days. Now, it looks like the focus could be a little bit better. So let's give the focus a tweak. That's blurry, blurry. It's not too bad, but it is a little bit blurry than what I would think is normal. But that might just be age of the tube, or it might be there's some carbon resistors around the place. It might be something to do with that. I know that with some other tech scopes I've played with, if you look back in my history, you'll see I've restored a larger benchtop tech scope. Was it 2215 or something? I can't remember exactly. But that had some bad resistors on the focus circuit, and replacing those brought that focus into very, very good sharp focus. So the they might need to be looked at. So there's I can see one down in here, one or two here. I can see a 4 or 5 down in there straight away. So I'll give those a test, and we can fix those up. Actually, I'm going to turn this thing off before I zap myself. So I'll have a look at those. Also, I've got another little upgrade I'm going to be doing. We'll put that in next and get all the other bits and pieces sorted, and hopefully that'll be good. Alright, time to look at that rectifier upgrade. I designed up some boards, and thanks to PCBWay, the sponsor for this video, they sent me some boards, and I thought I'd try their panelization service, see how that looks like, and it's looking like it's pretty good. They have an option there. You can either choose V-score or routing, or you can let them choose. And I thought, I'll let them choose. I don't care which one it is. And they chose the routing method. Little mouse bites along here so you can snap them out. And it's looking quite good. So I've got a stack of these boards. 5 of them actually, because it's under 100 by 100. Yep, under 100 by 100. So 5 of those as is usual. And you can see I've already snapped one out there, because that is now installed here. Look at that. Got a little bit of plastic on the back as an insulator, because the case has a metal, the metal shielding, so I don't want to touch that. And the original design actually has some plastic on the back too, for the same reason. We've got the bridge rectifier. There's the SCR for the protection. There's a Zener diode there and some resistors and whatnot. And it just plonks straight in directly in place of the old standard bridge rectifier, full bridge rectifier. And that is the protection circuit rectifier module thingy upgraded, and that's the service upgrade done. So this can basically go back in the enclosure. I'll put it all back together, and we'll see if it works still. Alright, it's all back in one piece, all back together. A little bit of a pain in the bum. I got the probe wires and the power cable here through their respective holes, which was a bit of a pain. You need like 2 pairs of hands to do that really, but I got it done. And the screen's in. It's got a rubber surround. It's a bit of a squishy fit, a little bit tight to get in there, but it's all done there, and all the knobs are in the right positions. So we are ready to turn this thing on. No leftover screws or anything. So I'll turn one of the lights off. I actually turn both of them off, so we can see the screen nice and bright. And let's flick that on. And we get nothing yet, because I have to turn on the channel. So I've got channel 1 hooked up to my function generator with a sine wave through a 50 ohm terminator and an adapter. A little bit loosey-goosey, but that's alright. And channel 2 is up to my other scope with the probe compensation, the square wave output. So we're about to see a sine wave and a square wave. So let's turn on channel 1 and see what that says. Oh yes, that's looking good. That is fantastic. Okay, channel 2 with a square wave. There it is. It's working on both channels. Awesome. Give this a bit of a tweak here. Yep. Yep. That's looking pretty good. Awesome. Oh, tracking the trigger's gone a bit funny there. But that, we'll give that adjustment. There we go. Yeah. I'm happy with that. That's working. I'll give it a little bit of a tweak in some of the settings on the side there. But that is done. Oh, and yes, it is actually running on the battery. So that is working. 100%. Fantastic. So that's about it, I think, for this video. We are done and dusted. So if you want to build one of those little upgrade circuits for the rectifier, the files will be down in the description below, the Gerbers and all that sort of stuff, and the instruction manual. I've updated the instruction manual slightly to make a few corrections. Yeah, that's done. So hope you found that interesting and somewhat informative. Stick around, hit that like and subscribe, and we'll see you in the next one.